Okay, ready? Here we go. All right. I don't know if you could see all the way in the back. I should have wrote probably with bigger font, but it is what it is. I have two questions. One was directly out of the review before your 10-1, 10-2 quiz. And last year, I mistakenly put the second question worded that way on that review. And it's out of order. It's actually, for last year's students, we had to make a change. What's the difference if you read them? The answer to that is the first, what you had last week was the change where I said, find a probability of answering correctly, specifically, I don't have that word in there, but to the first three multiple choice questions, and then incorrectly to the first three, then correctly to the fourth, which is very specific. Whereas the problem that I had on last year's worksheet, just sharing a story, but now the reason I'm sharing this is because it was out of order. This question was on the worksheet before we actually taught the concept, all right? And that's what we needed to understand. Find a probability of answering incorrectly to three multiple choice questions and correctly to a fourth. What's the difference? What's the difference between the two questions? Well, not the order necessarily, but let's look at the first one. Wouldn't you agree that the first one, this is how we did that? We said, all right, we have four questions. The first three I answer incorrectly. If I have four possibilities of choices, what's the probability I get the first one wrong then, if I randomly guess? 3 out of 4, which is what as a percent? I'm going to write that as a percent now. 0.75. And then the second one, we know and means multiply. The second one wrong. Well, that's also a 75. And the third one wrong. And I'm going to change colors for the purposes of these notes today. The fourth one right. What's the probability you get the fourth one randomly right in four choices? 25 if there's only one correct answer. And then that was the answer from your worksheet because I worded it that way for you guys. Last year, I actually said, okay, scratch that out, but all right, let's not talk about last year anymore. How do we do the next one? Well, the problem with this is when this is worded this way, this is a possibility. Wrong. Dang it. Go back. Wrong, 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 right. But is that the only way you could get one question right? No, you could get which one correct? The first one correct. And then the second, third, and fourth wrong. Or you could get the first one right, and then what? Second one wrong. Then third and fourth right. I'm sorry, second one right, third and fourth wrong, because the reds mean wrong, right? Or, what's the last case I didn't account for? The third one, right. So weird. Right, and then my wording is going to kind of be convoluted with what we're doing for the day, but the green represents getting it right. But what we're looking for is the probability that we get a question wrong compared to getting it right. We'll worry about that later. So each red should have a 0.75. Okay, and then just go ahead and write it out for purposes of understanding. When you understand what we're going to be doing, or at least why the numbers are where they are, you have a better chance of memorizing. And if you reject that, then that's why you can't memorize and you don't get A's. All right? Yeah. True story. And then, by the way, then I'm going to word it here so we put it all together here. This is why I'm getting this all filled out. Thrilling for the video. Okay, probably could have paused and then had these filled out for you. Okay, so this is what this is saying. Probability you get 3 wrong and 1 right. Well, I could get the first 3 wrong and the fourth one right. Or, oh, we got an interruption, darn it. Or, you get the first one right and the next 3 wrong. Or, why am I saying or obnoxiously? Because I'm obnoxious, but also why? You add these 4 possibilities. By the way, don't you agree that each fourth of these is 0.75 raised to the, come on, third, and then 0.25, what? raised to the first. And how many of these do you see are the possibilities? 4 of them. And I don't know what color to choose because I'm freaking out, man. Okay, but what? 4 possibilities. That's what that mathematically is equal to up above there. That's what you need to understand. Okay, so that's why last year the question worded as that, I cut that. That is a cut from last year's worksheet before we did this. It's improper because students would have had to get that right, done all 4 of those possibilities. And actually some did. They figured out that there was 4 different ways of doing that. Well, this is called a binomial distribution. Can everyone say binomial distribution? Isn't that fun? Hold on, there's another interruption. The same interruption with the same person with the past. Did you guys say binomial distribution? Did you? Did you? You didn't? You refused? Okay. Shh. Hey, students over there. Okay. Right there, right? I'll be watching you. Okay. Binomial distribution. You know what binomial means? What you looking at there? The time? What's binomial? What's bi? How many? How many? 2. Okay. This is why I think it's called a binomial distribution because there's only 2 possibilities. In the questions, you could either get the question what? Right or wrong. Okay? And that's what a binomial experiment is. There's only 2 outcomes. So let's put this down here. And if you were writing it out, that's fine. Maybe should have had it a little bit larger. And by the way, you know how I keep loving to do this. We used to do this in Algebra 2. This is actually an Algebra 2 book cutout because I'm living in the past. All right? And I always will. But we used to teach this to sophomores. And you may have seen it. You may have done this. I don't know. Okay, but anyway, if you had seen it, then it's a nice little review. So here we go from that Algebra 2 book. A binomial experiment meets the following conditions. There are n independent trials. Okay? All right, so in the last one, we had 4 trials, 4 questions. That's what that means. 4-question test, n would be 4. All right, of these 4 questions, what's the probability I get 3 wrong and then 1 right? All right, and that's how that would have worked. For each trial, there's only 2 possible outcomes. In the last one, it's perfect. Success or failure, right? Get it right or get it wrong. Boy or girl, probability of that. Just something that there's one or the other. There is nothing more than 2 possible outcomes. 3, the probability of success is the same for each trial. Just like in that multiple choice question scenario, there's 4 choices for each question. So therefore, that's a nice little binomial experiment. Each question has the same odds, same probability of getting it right as it is getting it wrong. So P is the probability of what you're looking for. I guess in that last question, we were looking for the probability of getting it wrong. We treated that as P. Therefore, 1 minus P, that's the complement of P. Getting it wrong was a 75% chance. Getting it right was a 25% chance. These add up to 100. Now, what I have written next here is just a difference of variables, because we do have a formula coming up that uses Q in the formula. P is the probability of success. Now, I know my formula down here for probability is, don't look at this yet. Let me get rid of this just to get, us focused on what we need to be focused on. P is a probability of success. Use Q as a letter for probability of the opposite, which actually is equal to 1 minus whatever P is. So if there's a 40% chance of success, what's the success chance of failure? Okay, or what's the failure rate? 60%, right? That would be Q, the opposite of the what we're looking for. I'm using the term success, failure. Well, now here we go. Let's go and reveal the formula. And actually, these 2 formulas are the exact same using different variables, and that's all that you need to worry about. Here we go. Let's focus on the Algebra 2 one first. So the probability of success. Oh, I thought I could keep it there. There we go. Hey, what is that C thing? What does that stand for? Combinations. NCK. Times P to the K times 1 minus P raised to the N minus K. What? So go ahead and write that down real quick, and then I'm going to go back up to our getting 3 right and 1 wrong probability scenario. Probably could stop the video, but I don't feel like it. So those watching at home. Do, 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 do. No, I won't do that anymore. Okay, let's look at this top one again. Where do you think that 4 came from? Well, I have 4 multiple choice questions. What's the probability I get 3 wrong and 1 right? So I have 4 questions, and what's the probability I get 3 wrong? By the way, to get them wrong, there's a 75% chance raised to the third. Hey, I already have that, right? And 1 right. And then why are we putting these numbers in powers, with the third power? No, because look, there's 4 different ways to get 0.75, 0.7, times 0.25. 0.75 to the third. What I want to get you guys okay over there? Because every time I turn my back, something's happening. Okay? There's 4 different ways, 0.75 to the third, 0.25 to the first. Okay? And then what do you think 4C3 is equal to, guys? What do you think 4C3 is equal to? What do you think looking at this? Come on. What's 4C3 equal to? What number? I'm getting closer to it. 4. Thanks. That was so suspenseful. Okay, 4C3 is 4 factorial over 3 factorial 4 minus 3 factorial. By the way, 4 factorial is 4 times 3 factorial. What happens to the 3 factorials? They cancel, and that's what that number means out in front. That's how many different ways we could answer 3 wrong and 1 right. And that's what I want you to get, as opposed to just being a formula shoving the numbers and I don't get what's going on here kind of thing. And then what's P to the K? P is the probability of success. In this case, we're looking for wrong answers. Isn't that weird? And there's 3. That's K. And then what's the other power? 4 minus 3, the leftover. These should always add up to how many trials there are. Very simple. Okay, so that's what the N minus K means. Now, for purposes of other formulas, this in pink over here is the same formula using different letters, which is not a big deal. What's the probability of X successes? Well, I changed K to X. Big deal. So now it's NCX times P raised to the X times, and then instead of 1 minus P, just putting the letter Q in there. Just so you know, Q is the complement of P, which comes from 1 minus P, which I have written up there right above that as well. So it's just different letters if you ever see this formula, but we have to use Q later for some other formulas. That's why I wrote that for you. Okay. Now, you can write this down or visualize it later because I do have a question about this. I stole it right out of the Algebra 2 book. It's a great description of a binomial distribution. Okay. So in this case, according to a survey, so we're going to treat this survey as scientifically valid for some reason, and we're going to talk about that as we go through surveys being, that. Let's just move on. So according to the survey, about 41%, as if we care, of the U.S. households have a soccer ball. So what percent households do not have a soccer ball? 41% do. How many don't? 59. If you can't figure that out, get out. Okay? Okay, that's locked in stone. This survey's already been done. This is what the percentages are. Now we do the next thing, which is a trial. We have nothing better to do than to go to 6 randomly chosen U.S. households and see whether they have a soccer ball or not. So the survey's set in stone. Now we're going to do an experiment. What can we expect from the experiment? And then we're going to draw a histogram for this. Okay, so what is this first thing that we have here? Probability K equaling 0. What does that mean? What does that mean, k equaling 0? Well, I go to all 6 houses and none of them have a soccer ball. Is that likely to happen when 41% of the households have a soccer ball? Yes or no? No. How many different ways can you get nobody having a soccer ball? There's only one. All 6 will not have a soccer ball. There's no reshuffling of that. Okay, so what's the probability that exactly none of the 6 houses have a soccer ball? 6C0. 0 houses have a soccer ball. 41% of the households do, so 0.41 raised to the 0 times 0.59. How many houses don't have a probability-wise soccer ball raised to the 6th power? Oddly enough, this is kind of a low percentage. 4.2% chance, because that's not likely to happen. Almost half the houses have a soccer ball. So none of your 6 that you choose have a soccer ball? Not likely. What's the next one say? That exactly what have a soccer ball? 1, Mr. Samuelus, and those that aren't answering, I don't know what's going on. By the way, how many ways could that happen? I could go to the first house and what? They have a soccer ball. What does that mean about the next 5 ones? They don't. Or the first one doesn't have a soccer ball, but the second one. Or the third one and all the others. Or the fourth, or the fifth, or the sixth, and all the others do not. There are exactly 6 different ways one of the households could have a soccer ball. Guess what 6C1 equals? Guess what 6C1 equals? Guess what 6C1 equals? I got a bunch of comatose human beings in this class to not know what that actually is. All right, come on, Chiefs. Let's go. Ah! Crazy math teacher. Are you okay? You're looking at me weird. There he is. I just got the answer. Holy crow. All right, and then 0.41 ways over. And then 6C2. Or what's 2? 2 houses have. And there's exactly 6C2 ways that 2 of the 6 could have a soccer ball, so on and so on and so forth. So if you want to write this down, these are all of the possibilities, all the way down to the last one. All 6 houses have a soccer ball. Well, there's only a 41% chance that an individual house has a soccer ball. So all 6 having a soccer ball, when you get it, that's pretty low. That's why it's less than 1%. 0.005 is 0.5% chance that all 6 have one. All right? Okie dokie. And I'll pause for a second to let that those that write this down. Talked outside of the video here with my second hour. Give them a little more nugget of information. All right, then remember the old histograms? And we can draw this data. And it's actually real simple. All you do is put the percentages on the vertical, and then we can put this in how many households each bin is, and that's how we number it. You know, we'd put 0 right here, not at the end, it's right in the middle. What's the probability of 0? Wasn't that like 4.2% or something like that? So this is 0.1044 4 is right about here. So you draw it like up that high. Then 1, that was like something like 17%. Then 2 houses, that was like 30-something%. I forgot what it was. Blah, 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 blah. So you can sketch that histogram real quick. And then some people might say it's very close to symmetric. Are you right, by the way? Is it very close to symmetric? Isn't it? Yes, Mr. Samuelus. But is it symmetric? No. Okay, so which way is it skewed? More of the data is on the left, so it's actually skewed right. And then we're going to come up with 4 specifically binomial distributions. This is how your worksheet begins with. This is skewed right. It's because P is less than 0.5. That's the stuff I was talking to you, those that really want to get a feel for this so they do well. That's why more of the data is early. That's why the probability of 0 houses is higher than the probability of 6 houses, because the probability is less than 50% that an individual house has a soccer ball. So that's why more of the data is on the left, okay, for this particular situation. So these are locked in stone. And then if you want to sketch this real quick, hey, what's the probability I flip a coin and I get heads? Nobody. Remember, My birthday's coming up. Just a cricket noise whenever I ask questions in class. Hey, what's 2 plus 2? I hate you, Mr. S. That's not the right answer. It is the right answer for you, but not for the question I asked. What's the probability I flip a coin and I get heads? What is it? 1 out of 2. So the probability to get heads is 50%, as opposed to probability of getting tails 50%. When the probability of a success is 50%, then you will have an exactly what kind of histogram? What do you think? Symmetric. And then the previous one, the probability was less than 0.5. Look at when the probability is greater than 0.5. That is an example of skewed what? Left. Okay, so here we go with these little things that you want to write down, which I've already said over and over again. Now you can write it. Okay, Mr. S, you've over-explained. All right, and then the kids are bored. Young adults, sorry, didn't want to insult anyone. Okay, another random survey. 65% of the households in the U.S. subscribe to cable. Done. The survey's been done. This is what we found. As long as the survey was valid, with a nice population to represent the whole, we'll accept the data. So now what should happen if I randomly start walking the streets and I randomly select 6 houses and ask if they have cable? Got nothing better to do. Find the probability that exactly 2 houses have cable. Here's the brass tacks of it. Just do it. Nike. And I'm not even asking. I'll do it once on the calculator for the video. 6 houses picked, and exactly 2 of them have cable. So this is what could happen. The first 2 could have cable, next 4 don't. Or the last 2 could have cable, and the first 4 didn't. Or the first and the last, and the middle don't. This is all the different ways that this could happen where 2 out of the 4 do not have cable. If you understand the beginning of my notes, how we did that problem that, poor last year students I accidentally put on that review when it was a little out of order. Okay? Boom, back to this now. And then, and then, okay, what's the probability that the houses have cable? 65%? And how many of them had cable? 2. What's the probability that they don't have cable then? 35. You asked me where that came from? You're not paying attention. What do these 2 add up to become? 100. This is the complement, the opposite of this. And then raise that to the what? Not 6th. 4th. These have to add up to 6. That's what the n minus k thing was. All right? And then go into the calculator, not to bore you, but this is how long it takes for my calculator to open. I hit it. Opening, 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 opening. Still opening. Opening. Hooray. Message? No. Okay, there it is. Okay, so what did I have to do? I had to go to math and then find right away probability. And then I actually type it first. The older calculators, you have to type 6 first, then the NCR. Scientific calculators, it's 6 first, then NCR button. And then 2. I shouldn't have to write the rest because there it is. 6C2 from last hour. Then raise 0.65 raised to the second. 0.35 raised to the fourth. Press enter. 9.51%. So this ended up being 0.0951, which if we don't know how to do percents, infuriating. Okay? Now, what's the problem with fewer than 2 houses have cable? I lost my E. What is that? What's fewer than 2 houses? 1 or 0. And what did I say? 1. What was the next word? Or 0. So what does that mean? I have to add these 2. So what I have to do to speed this up, because I could sense that we need to close this up, it's this, and you could type it as it looks. I'm not teaching how to type it on the calculator anymore. Sorry if I'm in the way. 5, right? 1 plus 5 is 6, correct? Right? Mr. L back there? Uh-huh. What's OR mean, Mr. L? Huh? What's OR mean? Plus. And then 6C0, 0.65. I should be calling on students. Seeing if they're even paying attention. There's a question. I can't say your name online. You could sue me for all my money. I got nothing. So what does it mean at least 2 houses have cable? That means how many houses have cable? What are all the possibilities? At least 2 houses have cable. So that means, okay, 2 or at least 2 houses have cable. That means 2 or more. So 2 or 3 or, we're rolling now. Sorry for that or. I'll get that fixed as he figures out the next number. Or, Mr. L, I'm losing you. Probability of, oh my gosh. I'm going to run right past you and jump out the window. 4 or, am I too close? 5 or, L. Oh, and then there's the 6. Here, it's right there. Or 6. Okay, now, do you want to write all 4 or 5 of these probabilities out, or is there a better way I could do this? Could someone help him? What could I do other than writing these 5 things out?
You could take the one you already found and just subtract it from
1 minus the complement of this. And the complement of this we just found on the previous one. This is the opposite of what we're looking for. And remember, all of those add up to 1, all the possibilities. So what I could do is find the complement. And look at what I did. I'm going to put this as a bracket too. Meaning find what's in the bracket, get that answer, and then take 1 minus that. A lot of stuff on a Monday, huh? Don't you wish we had SSR? I don't, because people that can't read during SSR, I want to throw a desk. You know, we take a day off of math. Wouldn't you just have the respect to read a book during SSR, wouldn't you? Isn't someone that doesn't read during SSR because they're too cool for school? Isn't that infuriating? It really makes me, that one person that ruins it for everybody else, it makes me want to cancel SSR for the rest of the history of this school. Because that one person, they just can't do it. They just can't. It's infuriating. Those people are why we have laws. They just can't live in a society and get along with everyone else. That's the problem. Drives me nuts. So in closing to these notes, there's 3 more things. Okay, now these are going to be things that we're going to... Is everyone okay? You all right? You're kind of new to this, so not to take in the notes and then the other stuff, right? Yeah, I know. It's like, ooh. All right. I don't even know if I took attendance. Okay, now, did you get that stuff about the SSR? Did you write that down? No, okay, all right. It won't be on the test. All right, now, mean. Anyone know what this letter is? I always thought it was a fancy M when I first started teaching this. It's mu. Okay, mu. Mu. Okay, mu. All right, mu is mean. Let's take that last probability problem where 65% chance of success, 35% chance of failure. Finding someone with cable, not finding one with cable. Okay, so mean, what's mean actually mean? Mean? Average. Okay, for these particular binomial experiments, mean or mu is n times p. N. How many households did I go by? 6. That's n. What's the probability that house had cable? 65. And then you can go ahead and type that in the calculator. I think it was 3 point something. And then before I wanted to go over these formulas, because we're going to go into this more basic, actually standard deviation is going to be huge all the way till May. We're going to be in and out talking about standard deviation and what it is and try to get a good feel for it, both you and I, all right, being honest. Comes from variance. And what I pulled off the internet this morning, variance measures how far each number in the set is from the mean. I think in an average sense. Where it comes from is 6, n, times n, which is 65%. And then remember what I said about Q if you were listening? Q is just the complement of P. All right? Q is whatever P is, the probability of success. Q is 1 minus that. Okay, and in this case it was 0.35. Then you get a number. I think we got something like 1.7 or I don't know what 1.3. You can type those three numbers down. I'm not here for you for that. Then the standard deviation, if you want to write that down, is the number used to tell how measurements for a group are spread out from the average. This is what statisticians like. They like to get these numbers and then see how spread out it is, and then some other things. That's a big deal. So a low standard deviation means that most of the numbers are very close to the average. A high standard deviation means it's much more spread out and farther from the mean. And then we'll analyze those numbers later. You don't have to do it now. Just find it. And all it is the square root of that previous number. So it's the square root of this product, which I think first hour gave me that number. And it was like 1.1 or so. I don't know what it was. You can type it on your calculator and find it. Okay. All right. So binomial experiments.